Okay, now what we're going to do is create a custom macro that's going to turn on that output. All right, so that means that we're going to create a custom macro that's not being used for anything, and we're going to have the PLC program that sees that once that macro is created, it's going to turn on that output on and off. All right. So first thing we're going to do is we're going to see which macros we are allowed to have. We're going to go into the CNCM directory, and we'll see, as I said before, that the macros are defined as mfunc3 or mfunc a number .mac. So basically these right here are custom macros that have already been created. So I'm going to create a macro, we'll call it mfunc13. All right. Okay, so let's go ahead and create this macro M13. I'm going to start off a new one. All right. What I like to do is basically put a header similar to what we see on top of the SRC file on the macro. All right. First thing we want to do is making that. Okay, we're going to define it mfunc13.mac. Okay. Let's give a little description. Macro that will turn on output 6. Of course, author. Today's date. Another thing that I typically like to do is I like to put right in the header if it's going to be using any kind of inputs or outputs. So as of right now, because I'm going to be tying it to output 8, I'm going to put in a comment here that it's using output 8. OT6 is out 6. I'm sorry, OT6 is out 6. And that's pretty much the end of our header. Put a few more there. Okay. Now is going to be the start of the actual macro. First thing that I typically always like to do is I like to put a comment or a little piece of logic that will skip the macro if it's either in graphing mode or in search mode. All right. Okay, so this line of logic says that if I'm either in a search mode or graph mode, then I'm going to skip to that block number 200, and that is the last line of the macro. What this will end up doing is if you're ever searching or you're graphing, if there's ever that macro in that program, if you don't put this line in there, then it's going to try to do whatever's inside this macro, and if it's waiting for various inputs to be in a particular state, it'll be stuck on there and it won't continue on. So by adding this line of logic, once you get to it, the controller is going to see it, say, okay, I'm in this mode, because one of those system variables is going to be set, and it's going to skip everything in the logic on there. Now, you might be wondering, how did I figure this thing out? Like, how do I know it's 4201 and 4202? Well, those are actually system variables for that. Now, if you end up looking in the operator's manual, now, easiest way to get to it would be pulling up the software. And then in the F5 CAM menu, you'll see a button for the manual. All right. Click on manual. It'll open the PDF version of the manual that you can end up searching. Now, what I typically search is I put in 50,001. That'll take me straight to the system variable numbers. Okay, and there's a complete list of all the various variables that the software ends up using. Now, if you wanted to, this is in chapter 11, so if you wanted to, you just could go to chapter 11 and search for that table as well. But we come down here and we see, all right, 4201 means that this thing, if it's set, it's in a graph mode. When it's set to 0, it means it's not graphing. And of course, 4202, if it's set, it's searching for something, and if it's 0, it's not in the search mode. So that's why we put in there, and we say, all right, if it's set, then that means that, yes, I'm in one of those modes, so then I want to skip out of that macro, because if not, the software will just be stuck in that in limbo, and it won't continue on. All right, let me just close out of that, and go back to our program then. Okay. All right, so here we are, we have that macro. Now, like I said, all we're going to end up doing is we're going to turn that bit on. So we're just going to say M94/13. All right. So that right there is going to send the request out. It's going to turn the 13th bit of this system variable associated with the M94, M95 callout, and we're going to modify the PLC program that once that bit gets set, it's going to turn on that output. Okay, but this is all that the macro is going to do. What I'm also going to do here is add a comment saying send request to turn OT6 on. All right, because that's what this is actually doing. All right, so I'm going to create this new macro called mfunc13.mac that all it's going to do is set the 13th bit in the system variable, and then I'm going to modify the PLC program that when it sees that bit being set, it's going to turn the output on. So now let me just save this file here. So mfunc13.mac. Once again, I put it always all types, because if not, it'll have it .mac.txt. Save that. Now I am also going to create another macro that will turn the output off. So now I'm going to create M13 will turn it on. I'm going to create an M14 to turn it off. So let's go ahead and turn off. And all that's going to contain is now M95. Okay. So the M13 contained the M90 or the M94, which was turning it on. The M14 is going to contain the M95, which is going to turn that bit off. All right, let me just save that. So right now I've created two custom macros, M14 and M13, that are either going to turn out OT6 on or off. All right, so now we go in and we modify the PLC program. So now I'm going to, once again, let's comment all this out so that this logic doesn't compete with anything that we're doing here. All right. Let me just copy this. All right. So essentially the logic is going to be similar to the logic that was over here on this one, and all that's going to be, instead of having switch 16, I'm now going to have it to where it's M13. And of course, M13, I haven't defined it anywhere, but I'm going to go ahead and define it in the system variable section. So let's go up there. And I'm going to assign that to M13. Okay, so now by this, I am defining this as the 13th bit in the system variable M94, M95. Okay, so when that thing is set, anything that's being associated with the M13 in the logic in the PLC program will be active. All right, so now that I have that, let's go ahead and save it. made a little comment in here about this. And compile it. Excellent. Didn't have any issues. So now I am going to power off the all-in-one DC. And that's ready. Reset that. Bring up the PLC diagnostic by once again hitting Alt-I. Now, I want to go ahead and actually issue the M code. All right. Now I can do it either A, running a program, or B, I can just hit MDI. MDI is manual data input. It allows me to put or enter in items one item at a time or one line at a time. So what I'm going to do here is go ahead, issue the M13, hit cycle start, and lo and behold, output number 6 is turned on. Now, of course, if I exit out of it, okay, output 6 is still turned on. Because as of right now, the only logic that we have in there is that that output will remain on as long as M13 is active. I can hit reset. That'll put the system into a false state. It puts the system now into a good state. But out 6 never turned off because the only thing that turned it on was an M13, and the only thing that will turn it off is if that M13 is not set. Now the only way to unset the M13 was using that custom macro, M14. So I'm gonna go ahead, hit M14, press cycle start, and lo and behold, output 6 turned off. So now we've just created two custom macros that turn an output on and off. A macro that turns it on and a macro that turns it off. Okay. Now if I wanted to, I could even have that macro associated with any of these aux buttons. I can easily do that using the parameters that are in the CNC software. So if I press F1 setup, F3 config, F3 parameters 188 through 199 are associated with the aux functions. Okay, so right now, let's say I want aux1. Whenever I issue or press aux1, I want that to turn on the output. And then, of course, if I wanted aux2, I want aux2 to turn off the output. All right. In order to have the aux functions create an actual or run a macro, it needs to be a value of the macro number with the 11. Okay. You may ask, how do I know that? If that information is actually in the operator's manual. Okay, let me go ahead and hit save, and let me show you. Okay, in the operator's manual, if you search for, I'll probably just search for 188 because I know that's where it starts off at. Okay, page. Okay, there we go. Parameters 188 through 199 are how the control can set up those aux functions to perform various different tasks. One of those tasks, of course, is this execute M code. Oops, right here, which is that M11. Okay, the M11 means that whatever number your custom macro is, you just add an 11 to it. For example, like the ones that I just used, I was using M13 and M14. So for aux1, I set it to 1311, and then for aux2, I set it to 1411. And by setting it to that particular value, that tells the CNC software that whenever I press that aux1 button, it will perform or execute that macro. Now remember that that macro is being executed because of the do aux key. All right. So if I had any logic in there that was preventing that do aux key from turning on, it would not turn on. For example, show you here. Let's go ahead and find do aux 1. Okay. See on here, it's telling me this logic that says if I physically press that button or the keyboard shortcut or the button on the virtual control panel, I am telling the CNC software to go ahead and perform whatever is associated with aux 1. And it'll do that for all 12 of them. Well, of course, it won't do anything for aux 3 because we've gone in there and manipulated or customized the PLC program to tell it not to have the CNC software do what it needs to when aux 3 is pressed, but to do what we customized the PLC program to do. So because I haven't altered aux 1 and 2, that means that I am going to use that software or those buttons to show you how you can easily add or call out a macro using one of those aux buttons. Okay, so let's go ahead and start the software. All right. Okay. So now, if I press aux 1, that will call out that M13 function and it'll actually turn on output 6. And as you can see, it turned on output 6. Now, if I wanted to, I could also go into MDI, turn it off with an M14 because that will still be valid. And I can go ahead and hit aux 1. Oh, oops, I'm still in MDI. I can go ahead and hit aux 1 and turn that output on. And if I pressed aux 2, it'll turn that output off. So now I've done two things. I've created custom macros that will custom macros that will actually turn an output on and off, and I have them tied to aux buttons on the VCP. Okay, now let's say that we want to create a macro that turns on this output, and then it waits for a certain amount of time, and then turns that output off. So rather than actually having another macro turn it off, we just want it to be time-based. The easiest way to implement this is in the custom macro logic. So what you'd end up doing is if you bring that up, let's say we work on, not the M14. Let's go ahead, open up that M13 macro, because that's the one that's actually turning it on. Okay, so here's the macro that turns that output 6, turns it on. Now we want to have it where we wait for a few seconds, and then we'll turn it off. Now to do that, just add a G4, which is the standard G code for a dwell, and the P5, which means that this thing will wait for 5 seconds. All right. Wait 5 seconds. And then after that time has expired, we want to go ahead and turn that off. Okay, so the way this macro is written, whenever we call out the M13, it's going to send the request to turn output 6 on. It's then going to wait 5 seconds, and then it's going to turn or send the request to turn output 6 off. All right, so I'm going to save it, and because I've done this in the custom macro, there's no need to compile a PLC program or anything because I haven't altered the PLC program in any way. I don't even have to restart the software because the macro, think of it sort of like just any standard G code. And whatever I wanted it to do, if I wanted the axis to move, I could put an axis movement in here. Your macro is essentially just another G code program. All right, so now that I've done that, let me exit out of this, bring back the Centroid software. So now I'm going to go, well, rather than issuing the MDI, I'll go ahead and hit aux 1. Turn that output on. It's going to count for about 5 seconds, and then you're going to see that output turn off. And there we go. 5 seconds lapsed, and that output turned off. So now we've added a built-in timer to that macro. Now let's do one more. Now let's have it to where after it waits 5 seconds, now it's going to wait for an input. And remember, we defined that input switch 16. So now let's go ahead and modify that it's going to wait 5 seconds, and then after it waits 5 seconds, then it's going to wait 101/16. And that means that it's going to wait for, switch 16 to close. Now, the M101 waits for that particular input to close. M100 does the same thing, except it waits for the input to open. So now on here, I'm also going to, let's say, inputs. Whoops. Okay, like I said, I personally love that if I'm using any kind of inputs, outputs, or memory bits, I actually have the things being set on here. Okay, so what this macro is going to do is it's going to, when I call out the M13, it's going to send the request to turn on output 6. It's then going to wait 5 seconds. After it waits 5 seconds, now it's going to wait for the input, which is switch 16, to close. And then once that closes, then it's going to send the request to turn off output 6. All right, so let's go ahead and check that out. So now, click the button, turned on output. Now my output's going through, and then you'll see a thing that says time, the dwell time finished. Now it's waiting for my input 16 to change state. I go ahead and flip that switch, and boom, you see that that switch got changed into that state, and at the same time, that also turned off output 6. Now, let's bring input 6 back into the open state. Now, if you'll see that when I hit it again, I'm flipping this input, and nothing happens. Not until the dwell actually expires will that state of that input end up altering the state of the output. That's just because solely on how the custom macro was programmed. So now we've created a custom macro that also has a built-in timer and can also look at an input.